Hi, welcome back to the last chapter, which is from the textbook 4.7 and 4.8. So I'm combining 4.7 and 4.8, which is the simplification of forces and couple system and their further simplification. So it's like you want to simplify the forces, complicated forces. Sometimes you can have more than one forces. How are you going to simplify that? Or you can have a couple system which is like so many couple systems. How are you going to simplify that? So at the end of the lesson, you should be able to determine the effect of moving forces, and find the equivalent force couple system for a system for force and couple. So this chapter is specially designed for you to actually make your life simpler. So you just need to pay attention. So you see, the applications is just so many applications in the places where you have too many forces that's putting, that's applying on the on the diagram, on the body. So you just want to simplify them so that it's easier for you. So let's look at these. Simple one. I'll just show you here. So you remember what I told you about force. Force is a vector. So remember about vector. If I decide to shift this green line here, can I do that? Yes, I can. Okay, but the most important that I need to do is two things that I need to maintain. One is the direction and one is the magnitude. So if I were to take a ruler and draw the measure this as 5 cm, wherever I shift, it has to be 5 cm. And look at the angle here. The angle here is 180. So it means the new place that I draw has to be 180. So this is the unique part of the force. But of course, when you shift the force, there are two things. You're shifting either parallelly or perpendicularly. Okay, I'll explain both to you now. Just pay attention. Look at this. So we have this force here acting at the edge there. So I'm going to shift this parallelly. I'm maintaining the distance. I'm maintaining the magnitude and I'm maintaining the direction. So when you shift from an end here to here, you don't imply anything. It can be freely moved. That's it. So you're going to have the same thing. Whether the force edge there or whether the force is down here, it's going to be the same. Can you see this one and this one? Now, if I shift a perpendicular force, what does it mean by parallel and perpendicular? Can you see parallel means this way, The line is same line. Perpendicular means 90 degrees apart. So can you see this force here? This is 90 degrees. Now, if I decide to change from this edge here to a new location here, what happens? The force moves, because as long as you maintain the same distance and same direction, right? No problem, the force moves. But because it is perpendicular, so what happens is it generates a moment. So how do you calculate this moment? You have to take force times distance. So additional, you have a force which you have shifted and you have a moment that's being generated due to the shift of this force to the edge here, just because this force is perpendicular. You get it? So this is how it happens. So you can actually simplify. So if you can have so many forces here, right? So many forces, what do? You can just combine all and shift to the edge here. Finish story. So that's what I'm going to explain in this particular chapter. So why do you do that? Because there's so many forces and couple. Example, this is an I-beam. You know why it's called I? Can you see the shape? It's I-beam. You have all this kind of beams, in structures. So you can have forces that's being applied at all direction. You have a 300 force up here, and then you have got a 800 force up here. It can be more than that. So you want to shift to this point O, because you need to calculate what is the strength and what's the load that can be applied at O. So what do? So this is where this chapter comes into handy. Okay, you cannot just simply take 800 and plus with 300, because this is vector. Sensitive, it's very direction sensitive. Okay, so likewise, you see this 500, there's an existing moment, and then there will be a moment generated due to the shift from this 300. So all this can be calculated. So that is the important part of this chapter. Okay, so if you see, this is what I've explained earlier. They say that from up here you can just shift it to the back here. Simple. Whereas when it's perpendicular, when you shift, so you will be generating a moment. Okay, so that is the difference. Okay, So simplification of a force and a couple system. So you can have many types of forces. Forces. I can add few more forces as long as this is represented in I, J and K. What can you do? You can take the F2 from IJK and you can add on with the F1's IJK, and you can add on with the F3's IJK. You can keep on doing it as long as it is in IJK. So you have to actually be very thankful to Uncle Cartesian. Yeah, I call him Uncle Cartesian, the scientist who's behind this IJK, because without him you cannot do this simplification. Likewise, moment will also be in IJK. So you can have moment 2, moment C, whatever. How many more moments? No problem. You can just calculate. And then what you do at the end of the day? You just have to add it on to IJK. Yeah, IJK. That's it. Move to IJK. Okay. So that's how you work towards it. Can you see this? Force resultant. And then we have MR naught, which is MC plus with MO. Now you can ask me, what is the difference between MC and MO? Okay, when you have an O here, it means the moment is referred to point O. So mostly point O will be a common point that you can decide is a reference point. Yeah. Okay, then you can have this MC or MA or MB, where C is mostly represented by center, the center of gravity of that particular object. Can you understand it or not? Yeah. So if you have MA, yeah, what is MA? It's at point A. Yeah, the moment at point A. When we have MB, what is it? At point B. Or MC will be, if unit, yeah, is the center of gravity. It means the center of this object. So because this is not evenly distributed object, the MC can just be anywhere. Look at this. This MC is down here. Yeah. Okay. So it depends. O will be just a general another point, like A, B. You can have O, you can have P, you can have whatever name. Yeah, that just represents which location it is in. Okay. So the application in your daily life, you have so many things. Yeah, you see, you have a traffic light. I don't think so. We see these kind of things in Malaysia, but mostly in US. Yeah, you have a traffic light, hanging traffic lights. In overseas countries, this is very common. Yeah, Malaysia mostly you have a pole at the side here with the traffic light, right? Okay, so maybe in your place in Malaysia, maybe you have, I'm not sure, but in my town, we don't have this kind of things. Yeah. Okay, so we have W1, W2, you can centralize it to the part O here, to the H here. Okay, so that's how it's being done. So this is the purpose of this chapter. Okay, so there's examples here. As usual, I'm not going to go through examples in the lecture note. I will directly go to the examples that is in the textbook itself. So what is further simplification? No, sorry, this is another topic. Yeah, this topic I'm not going to cover here because I'll be covering this topic in the centroid lesson. So that's the reason why I'm going to skip this part in this chapter and I'm going to move on to chapter 8. So you can see the same thing reappearing in the subsequent chapter. You have this in chapter 6. I'll be using this in chapter 7 and I'll be using this in chapter 9. Yeah. So that's the reason why I'm skipping. So this will be the end of this chapter. But of course, before that, I'm going to go to solving example 4.14. Yeah. So 4.14 is actually from the textbook itself. Yeah. If you look at the textbook, you can just refer to 4.14. I've just snapshot the same thing from 4.14. Okay. So we have got this object here. So it looks like a brick slab, so I'm not sure what is this, the cross section of it. So we have some forces down here, forces here and forces here. So what does the question say? You have to simplify all the forces and shift it to O. Yeah, you shift it to point O. Can you see that? Yeah, you need to shift this whole thing to point O. So how are we going to do that? Okay, so you need to pay attention here. Okay, I'm going to be a bit quick here because this is something that we have done in previous chapter. So we need to find force resultant x-axis and force resultant y-axis. Yeah, so 3 you can resolve it to x-axis and y-axis. 5 we can resolve it to x-axis and y-axis, but this 4 here is only existing in y-axis. So let's do that. So we have 3 which is in x-axis, cos 30, settle. And then we have this 5, which is in x-axis, 3 over 5, yeah, 3, can you see the flat one? 3 over 5, yeah, 3 over 5, right? The flat one, 3 over 5, so multiply with 5. Okay, we have solved for the x, which is now pointing 5.598 on the positive side. Okay, keep that aside. Now we're going to do for fy. So we have a component fy here, fy here, and fy here. So we have 3. So we have 3 sine. Okay, and then we have 4 over 5 times 5, and then we have an existing 4. So please be careful of the negative sign. Whatever that's pointing downward for y-axis will be negative, and whatever that's pointing upward is positive. So with that, we have 6.5 pointing downward. What does it mean? So the graph, the final resultant will look something like this. We have like these, and we have like this. Do you understand? Yeah. So where will the force resultant be? The force resultant will be here. Okay, so you have to be very watchful. This is very important, the direction and which angle is going to take. Yeah, so if I were to write this is going to be 5.598, and then this will be 6.5 here. So you find the resultant. What's the resultant? You use Pythagoras theorem. So this is 8.58 angle. Look at the angle. The angle is very important because you can have 49.3. How many 49.3s you can have? Look, you can have here either 49.3. You can have here either 49.3. You can have here 49.3, or you can have the age. So you have a combination of 1, 2, 3, 4, 5, 6, 7, 8. 8 49.3. So you need to be very, very careful in to determine where is the 49. So this angle 49.3, can you see? They're actually taking y, yeah? Y over x. So where will the angle be? It will be here. So 49.3 is actually sitting down here. So it will be something like this. So it's very important for you to actually draw where is the 49.3. So this is your axis. This is your angle. So you just, that signifies. Yeah? Okay. Wait a minute. Did I say something wrong? Oopsie doopsie. The angle is... Oh no. The angle is here. Yeah. Y over x. You just need to tilt your head a bit, okay? Yeah. I made a mistake, yeah. So it will be up here. This is your 49.3. So the angle will be something like this. That's your resultant. Okay, so that is settled. So we have done with force. So you can actually shift the force to the H2O. No problem. Yeah, problem solved. But the problem is, you see, remember what I told you when you're shifting the perpendicular forces. Okay, so we need to revisit the forces. Yeah. Okay, so we have settled this. I'm going to erase all this because it's so messy, right? Okay, let me just erase everything. Give me a few seconds. Okay. Now we're going to move on fresh to moment. Okay, now let's look at moment. Okay, so because you shifted your force of Fry and Frx to this H here, you have actually generated moment. So which are the forces that will generate moment? Yeah, almost all in this case, isn't it? Because this is perpendicular. This one you can make it perpendicular and parallel. Okay, and then this one you can make it perpendicular and parallel. Okay, so let's look at it one by one. Okay, so we are going to visit the first one, which is 3 kilonewton sine 30. What are you making? 3 kilonewton sine 30. It is up here. Yeah, standing up there. Okay, let me just use a bit of color so that you can differentiate which is for which. Yeah, 3 kilonewton sine 30. It will be here. Okay, remember what I told you about distance? How do you shift the distance? Okay, you need to bring it here and then you shift it here. So what is the distance? 0.2. Okay, can you see that? 0.2. Now positive of negative, it is actually rotating this side. So it will be positive. Okay, settle. That's the first one. Next, we're going to use green color. It is 3 cos 30. Okay, going around point O. So what is the perpendicular distance? 0.1. Can you see that? This is going to be negative because it's actually moving clockwise. Okay, so you have settled. That's the green part. Okay, next we're going to move on. I'm going to use a blue ink here. You're focusing using colorful things so that you can see the difference, yeah, the difference of which one that I'm talking about. So we have this filler here. I'm going to make it parallel. So we have parallel component will be 3 over 5 multiplied by 5. And what is the distance? Can you see? You put a ruler here, it will be 0.1. So can you see that? 3 over 5, 5, 0.1. Now this one is going to go this way. So it will be positive. Okay, so can you see positive there? Okay, that's settled. Now I'm going to use another ink. Yeah, what color shall we go for? Purple. Okay, so we have this component, which is a vertical component of the 5. 4 over 5. 4 over 5. 4 over 5 multiply 5. The distance would be from O will be 0.3 plus 0.2. That will be 0.5. Can you see this? Why is it negative? Because it's going clockwise around this side. Okay, then the last one. Okay, let me use another color, orange. Okay, the last one will be this 4. Okay, this 4 is only at the distance of 0.2. So 4 times 0.2, and then it's going this side. So it will be negative. Okay, so now you sum up the whole thing. When you sum up the whole thing, you're getting a negative value. What does it mean? Don't get panic. Negative value just shows you that it is in the clockwise direction. So this is how you simplify. You simplify the what do you call the forces, the complicated forces that is in the question. Okay. So we have done this particular chapter. Okay. There is further simplification, which is similar. Okay. I'm just going to guide you here. Now, further simplification, the second part of the chapter, which I've actually covered also. Yeah. So what it does here is that, okay, let's look at example 4.17. So we have what? We're going to replace the forces in the couple moment to force O. Okay, we're going to shift it to O, similar like what we have done just now. But it's just that this fella has got an additional, they only want equivalent resultant force. They don't want, okay, they want to replace the force in couple moment acting on the beam by an equivalent force resultant and find its line of action. Okay, that's the unique part of this question. Find the line of action measured from O. Okay, this part I need to cover. Yeah, I need to show you how do you do that. Okay, so now we're going to shift everything to point O. Okay, we're going to shift everything to point O. So let's do it. No, actually we are not shifting it to point O. We are shifting it to a common point which we do not know what is the distance from O. So we're going to find the O. Okay. Okay. This is slightly different from what we have done before. Yeah. So pay attention here. So we have 4. The first thing to do is to just blindly find the resultant forces, which is Frx and Fry. Okay, so this one can be resolved to 2 components as well. And then what else forces we have? We only have 2 sets of forces. So what is in Frx? We have 8, 3 over 5, 8. 3 over 5, 8. So we have 1 force here, Frx. And then in Fry, we have 2 forces, which is 4 and 8. So we have 4 and 8. Okay, so we have 2 forces. Now we find the resultant, which is 5.37. And then we find the angle, which is 26.6. How do you get this? The x-axis is here, 4.8. And then the y-axis is here, 2.4. So where is the angle? The angle is here, 26.6 degrees. Okay, so that's done. Now, the thing is, we have found the force resultant. We have got the force resultant in x-axis and also y-axis. But now where is the location from O? The previous question, we shifted to O, right? So this one is not like that. This one is somewhere in the, somewhere along the beam, but we don't know how far is it. This is what we're going to find, okay? So we have the force resultant, keep that aside. So we're going to move on to moment, okay? We can only find the distance with the moment, summation of moment. Okay, so what we have here is that 2.4, we must equate the force Fr about point O. to the sum of moment of the force and coupled moment at point O. So we want to find what's the distance to point O. Since the line of action FRX, X to point O, only FR produces moment. You remember what I told you? Because FRX is a parallel force. So FRX is not going to cause any, any distances or any moment. It's only the perpendicular ones that is going to cause the moment. Do you understand or not? So that's the reason why they only look at the perpendicular forces. Okay. So now we are taking moment at point O. So where is point O? Point O is at the edge here. Yeah, this is point O at the edge here. Okay. So we don't know where is this location. We just place it anywhere. Yeah, anywhere. You can draw here, wherever you draw, but let it be along that along the beam. On the beam itself. Yeah, it cannot be somewhere outside the beam. That's illogical. So the next thing what you do is you do this. 2.4. Yeah, the force that is in the question. Yeah, multiply with a distance d, which we don't know. Yeah, 2.4 multiply with the d. Now what is this 2.4? 2.4 is from your resultant. Okay, so this side will be all from your resultant, and this side will be the original, the one that's on the original question. What does it mean? Look here, they are actually comparing these two diagrams. This is the original and this is the resultant. You get it or not? Yeah. So if you see the original, let's look at the original. 4 times 1.5. 4 times 1.5. And then we have 15 that is existing on the rod itself, on the beam itself. So we just have to put there negative 15. Why negative? Clockwise. Okay. And why is it negative here? It's also going clockwise. You see this force is going to go around this side. Okay. So remember, this part is the original in the question. And this part is the resultant that we have calculated. Resultant. Okay. So now I'm going to erase everything. Now let's look at this thing clearly. For some reason my eraser is not working. Finally it's working now. Okay, let's look at this. Yeah, when it's too messy, you can't see the thing, Yeah. Okay, let's look at this. So we have original 2.4 multiply d. Okay, and then we have, we have the resultant 2.4 multiply d, and we have the original part. So when you solve this, you will realize the distance of the resultant is 2.25 from where? So this d distance is 2.25 from point O. So which means the interpretation is, finally your resultant will be located 2.25 from point O. Now this is an exam standard question, yeah? Yeah, this is very common in questions in the exam. So I want you to pay attention and also solve the questions that are in the examples. Yeah, example right up to example 4.20 and upload them. Yeah, and also pay attention on this particular subchapter. Yeah. Okay. With that, we have ended chapter 4. I will meet you in the next chapter. Thank you.